In this video, we will cover density and calculations for density. So density is a physical property of matter that describes how closely packed together the particles of a substance is. The more closely together the individual particles of a substance are, the more dense the substance is. The less they're packed together, the less dense the substance is. So as a result, each substance has a unique density to it. Density measurements are useful for identifying substances. This chart here provides a list of substances and their densities as well. So each of these substances here, you can see, has a different density. So determining the density of two items here, let's say between bricks and aluminum, would allow you to differentiate between these two. Or let's say you have two things that look the same, such as aluminum and steel. Determining the density of that would allow you to determine which item was steel and which substance was aluminum. So from the chart, you can see that bricks are denser than feathers. This means that the mass of the bricks are packed into a smaller volume. So a metric ton of feathers will occupy a volume of almost 400 million centimeters cubed. That's about the size of 4 tractor-trailer trucks, while a metric ton of bricks would occupy 500,000 centimeters cubed. That's about the size of a large screen TV. The space between the mass and the volume of a substance is what defines the physical property of density. So density can be calculated using the following formula. So density is equal to mass divided by volume, or m over v. The units of density for solids are generally in grams per centimeters cubed, where 1 centimeter cubed would be the equivalent of 1 milliliter. The units of density for liquids would be grams per milliliters. So the units differ slightly for solids and liquids, but ultimately they mean the same thing. So it's a ratio of mass to volume. But in solids, the volume is given as centimeters cubed. When graphing density, this can be presented by graphing volume versus mass. Density graphs can be used to estimate the mass for a given volume or the volume for a given mass. So if you know if you have a graph and you know the volume of the substance that you're dealing with, you can determine the mass that that substance would have. If the mass volume data for two or more substances is plotted on the same graph, the substance that is most dense will have the greatest slope. And just keep in mind that the density of any object should always be the same. So you should have a linear line that always maintains the same ratio. So we'll look at this graph here. In this graph here, we have volume on our x-axis, mass on our y-axis, and then we have 3 lines here that represent 3 different substances. The solid line here represents alcohol. The dashed line, represented here, represents water. And then the dotted line is that of salt water in terms of density. So from the graph, we can determine which sample is the least dense, so which has the lowest density. And from the graph, that'll be the substance with the lowest slope. And in this case, it's going to be the one with the solid line, which is alcohol. So we can say alcohol is the least dense. And then we're asked to calculate the density of each sample. We'll just do an example calculation for one of the samples. But when calculating density or any other type of calculation in grade 9 science, we can use what is called the GRASS method. So the GRASS method, the G stands for given, and this is what you are given within a question. So in this case, this information would come from the graph that we are being given. And so we're going to calculate the density of alcohol, and here we'll choose a point off of the line to do our calculation. In this case, we'll use one where We don't kind of have to estimate anything. So if we look at the volume of alcohol here, we find 70 milliliters. We draw a line up. It hits right on a line that intersects our y-axis nicely, and one of these points here on our y-axis. So for a volume of 70 milliliters, we have a mass of 60 grams. So this is where the volume 70 milliliters comes from, and the mass of 60 grams comes from. The R in GRASS stands for required. So what are we being asked to find? In this case, we're being asked to find the density. The A in GRASS stands for analyze, and this is the equation that we are going to use. So in this case, because we're being asked to find density, we are going to use our density formula. So the S in GRASS stands for substitute, or solve, whatever you want. And this is where we will take our given information and substitute in to our formula here. So for our calculation, we have a mass of 60 grams. So there's 60 grams. We have a volume of 70 milliliters. Here is 70 milliliters being substituted in for the V. And then we can now solve. So when we do 60 grams divided by 70 milliliters, we get a density of 0.857 grams per milliliter. And then the last part of the GRASS is the statement, the therefore statement. So we can say, therefore, the density of alcohol is 0.857 grams per milliliter. So we can calculate the density of the rest of our objects, so the water and the salt water. You can do that on your own. We can also interpolate data from our graph here. So a density graph can also be used to estimate or interpolate values within the graph. So the first question here asks, what mass of salt water has a volume of 55 milliliters? So if we come to our graph here and we find the line for salt water, we can find a volume of 55 milliliters. We can trace a line straight up to where the line for salt water is, and where our line would intersect that line for salt water. Draw a line over to our y-axis and then estimate what that mass would be. So in this case, we could say that the mass is about 58 grams. If you said 57, that would probably be okay. If you said 59 grams, that would probably be okay as well. So it's an estimate, so we'll say 58 grams. In the second question, we're asked what volume of alcohol has a mass of 20 grams. So again, we find that line for alcohol. We find 20 grams here for that mass. We'll draw a line over to the point where it intersects our line for alcohol. When it intersects that line, we can draw a line down to the volume and estimate that volume. So in this case, our volume is 24 milliliters or 25 milliliters, 26 or 23. It's a range. It's an estimate. In the following examples, we will use the GRASS method to solve some word problems. So here we are given a small piece of gold. The mass of the gold piece is found to be 75 grams. The volume of the sample is 3.9 grams centimeters cubed. Calculate the density of gold. So in the question, we have to identify the information that we have been given. And so what we are given is the mass of the gold piece, which we're told is 75 grams. And then we're told the volume of the sample is 3.9 centimeters cubed. In the question, we are being asked to calculate the density of gold. So required is the density. To calculate that density, we will use our density equation. So density is equal to mass divided by volume. We can then take our given information and substitute it into the appropriate spot in our equation. So we have a mass of 75 grams, which we'll put in for the M, over a volume of 3.9 centimeters cubed, which we'll put in for the V. So we get 75 grams divided by 3.9 centimeters cubed. And then when we solve for that, we get a density of 19.23 grams per centimeters cubed. And then we can have our therefore statement. So therefore the density of gold is 19.23 grams per centimeter cubed. In the next example, we're asked what is the volume of a tank that can hold 18,754 kilograms of methanol whose density is 0.788 grams per centimeters cubed. So we'll identify the information that has been given to us. We're told that we have a mass of 18,754 kilograms and a density of 0.788 grams per centimeters cubed. Remember, density is always in units, is always in grams per centimeters cubed or grams per milliliters. So in this case, our mass is in kilograms, so we will have to convert that into grams. To do that, keep in mind that 1 kilogram is made up of 1,000 grams. So in order to go from kilograms to grams, we will need to multiply by 1,000. And when we do that, we get this rather large number here. I believe that's 18,754,000 grams. Now, we're required to find the volume, or we're being asked to find the volume. So in this case, we can use our density formula again to find that. And in this case, because it is density is equal to mass divided by volume, and we are being asked to find the volume, we do have to rearrange our equation. So here, our volume on one side of this equal sign here, we are dividing by volume on the one side to isolate volume by itself. If we move it to the other side, or if we multiply both sides by volume, volume now will be multiplied by density when we move it over to the other side of the equation. So here we have volume times density is equal to mass. Volume is not quite isolated just as yet, so now we have to move density. So if we divide both sides by density, we can eliminate density on one side of our equation, or if we move it to the other side of the equation, because we're multiplying by density here, on the other side we're going to be dividing by density. So our final equation that we're going to end up using is volume is equal to mass divided by density. So once we have our equation now that we can use, we can go ahead and substitute in the values that we are given. Remember, we have to work in units of grams, not kilograms. It's important that you pay attention to units. So we take our 18,754,000 grams divided by our density of 0.788 grams per centimeters cubed. And then when we do that calculation, we get a volume of a really big number here, centimeters cubed. And then, we can have our therefore statement. So therefore, the volume of methanol is like this really, really big volume. That's like a lot of millions of liters of methanol. It's a big tanker, a big tank. So that is the end of this video for density.